Hello, everybody. Today we are going to test another project which is public, and it is titled the Panda Arm Simulation. And first of all, for testing this project, I am going to use Asimovo Local. For that reason, it's important that if you don't know what it is, please um check the documentation and the video that is attached to this video, please. And then you will be able to understand how I have started my Asimovo client and now I can work locally. It is very suggested and a very helpful tool. So give it a try. So let's go to the project and let's see if we have you have or I have a local workspace. Well, I don't have. For that reason, first of all, let's see if the project assets, and let's also see the documentation of this project. Well, uh, here we can see that the project has the Panda Arm robot. Then, the word is the Tugbot depot, and it has two components which are algorithms for this robot. So let's see if this project has uh, workspaces. It appears that yes, it has workspace. So um, for creating quickly a workspace, let's use this and then select the Asimovo Panda Arm demo. Yes, we are basically mm, using a workspace that was already created. Um, in this case, I am the creator of that workspace, and I am completely sure that I added the robot, the environment, and the two components. Um, for that reason, I am using that workspace. Well, let's wait for a moment. And we can see um, the launch files of this project. Well, since we are not working with, in Asimovo Cloud, I mean, using, we are using local workspaces and not the cloud workspaces. Well, we don't need this launch file because this is just for running Gazebo on the web, on cloud. Okay, our workspace is already created, so now we are going to open the workspace. Remember that it is a local workspace. Okay, fine. It's started. Fine. It loaded really fast. That's nice. And since we don't have to launch this, we're going to launch the war. Then we are going to spawn the robot, and then we are going to try these two um, well um, programs. To be honest, I don't know uh, what does this project, but let's try it together. Okay, let's close this. I consider we don't need them. Uh-huh. tools, terminals, tools, terminal. Let's use four terminals. Now, um, okay. hmm Here, yes, it is not necessary. Let's see. Here it is introduction. This project is works with Gazebo, well, with Rose to Humble and Gazebo Fortress. Sorry. And well, the assets are the following, and we have to build the project. Colcon build, and then we need to source install setup.bash. Well, okay, we source the install folder. Okay, we source on each on in all the terminals. Okay, what else? Now we are going to launch the world, but since we are working locally, uh, it is mm, a good idea to set our GPU in order to have a simulation that runs smoothly. So let's use these exports. Let's export these environment variables in order to have activated, well, in use our NVIDIA card. You can see that the NVIDIA card is in use. So now let's use this, but let's see the arguments. Oh, I think, yes, for some reason. Okay, now it's well. Since we are not working on the cloud, we need to set this argument to false. And the other is okay because we are using Asimovo Fortress, so it is okay. And the other things are not necessary. So let's launch the, and you can see that we are using Asimovo Local because it is open in our local computer. It is not on cloud. So let's press wait, and well, let's be patient. Okay, I hope the simulate. Okay, here it is the pod. You can see that when we work with GPU, the simulation is very smooth. Okay, now let me put the simulation here. Okay, wait, sorry. Then let's run the second command. Is spawning the road. The next command. Okay, okay. Here is the Panda Arm. It was created. I'm not sure if topics are available. Let's see. Okay, um, it seems that it is necessary to bridge. So I suppose that the next um, launch files will do that because they are not indicating what they are doing. So let's launch this and let's see what happens. In this world, you can familiarize yourself with the basics of robot arms and control. The project includes a robot arm and a red brick in a depot environment. You can control the arm with GC, ignition, and ROS2 messages. Okay, how to launch? Okay. Uh, Let me put this here and this. Okay, that command spawn this object, and let's make bigger this terminal. Sorry, and let's run the last command. Launch play brick. Okay, it is a brick, and now we are going to launch the executable. Well, the program for moving the arm. So that's it. Okay, I I can see that that things well that this is they are bridge for the topics. Okay, but what else? You can find example commands for controlling the robot arm with GC, iron harmonic, and ignition, humble fortress image, and those two messages in the file. Okay. They are files. Right. Sorry. Well, this time let's see them. Well, that we are going to use the code editor and check what is what is there. Home Asimovo assets, robot arm. Oh, this is from my last session, I think. Asimovo assets, robot arm, source. Well, uh, you can find example commands for controlling the robot arm with GC, but we are using ignition and done and the ROS2 messages in the file. Okay. Uh, source extend sh. Okay, if we send these commands, we can control the R. And in source, the same path, extend ROS sh. Well, it is strange. Assets robot and one source extend AH. Well, here I don't see an extend ROS. Well, here to control everything is commented. Well, let's try. Ah, here I know. GC topic. Hmm, let's try. Okay, CD, assets, robot arm, S, oh, ls.l, gmode plus x, um, extend the sage. Let's see if it works. Okay, if it don't work well, let's run the commands manually. Okay, yes, we can use GC because we are not working with gazebo sim. We're working with ignition. Well, let's do simple. Okay, control commands. Well, we don't need this. Let me see if I can. Okay. Okay. Control optimize. Give me a moment. Let's copy this to one moment here. Let's create an empty file. A file. Uh, Nothing. Okay. Just to topic put control echo ignition topic sleep tree. Yeah. Yes. It seems to be useful. Okay. Control with ignition command. Control with roast to messages. Yes. Let's copy this here and let's try. Okay. Okay. You can see that now. Oh, oh. I hope the robot doesn't collide. But you see, by using ROS2 command, well, ignition commands, the Panda Arm is moving. Oh, it almost grasped the brick. Oh, let's try to move the brick, but I think it's too late. Or maybe not. Mm, oh, oh, I think the gripper opened it. Well, okay. Well, I didn't write this, uh, but I am completely sure that you can modify the commands in order to do something different and really nice. Oh, okay, I understand now. This project basically moves the this small brick to this point. Well, you can try to do more interesting things. Maybe you can try adding more bricks, maybe placing, well, doing pick and place task and many other things. So it is a very interesting robot. So well, I am going to press Ctrl C and now, well, finish the bridge, the topics bridge, and I will close the simulation. You can see that now there is no simulation. Well, this where I commented everything. I can delete that file. And well, that's all for this video. I hope you find this robot, the environment, and that script useful. And well, I invite you to try other projects and also to test uh, robots, environments, and start creating your own components that are basically Rust2 scripts that perform algorithms. So see you in another time.